Okay, so basically, um, I was planning on making this video for a while now, but I kind of changed my mind because I waited too long, and it seemed like everybody already got it. But I changed my mind again because I was wrong. So this is an IVT video about how IVT works, and that's pretty fun. So we're gonna do number 44 on page 129. And yeah, the flashlight's annoying, but trust me, it's significantly more annoying without it. Um, so let's go do that. We already did this problem, by the way. 129 was a part of the homework for 2.5. It's pretty wild. So number 44 is basically saying, suppose a function f is continuous on from the interval 0 to 1. So there's going to be a continuous line from 0 to 1, except at where x equals 0.25. So from 0 to 1, there's going to be a continuous line, except there's probably going to be like a hole or something at 0.25. Such and in that f of 0 equals 1 and f of 1 equals 3. So we know that this continuous line is going to be in like the y range, 1 to 3. Let n equal 2, and so n equals 2. Sketch two possible graphs of f, one showing that f might not satisfy the conclusion of the IVT, and one showing that f might still satisfy the conclusion of the IVT, even though it doesn't satisfy the hypothesis. So we'll start with what we know. We know that f of x, hang on. We know that f of x is continuous from 0 to 1, and that includes 0 and 1, and f of 1 equals, or f of 0, my bad. F of 0 equals 1, and f of 1 equals 3. So, and also that it's discontinuous at x equals 0.25. So, basically, actually 1 sec. So I have like a sample graph here. The x is, actually, sorry, I should probably do this so we know from 1 to 3. So we have 2 points that we know exist, which are 0, 1 right here, because f of 0 equals 1 and f of 1 equals 3. So 1 and then 3 right around here. And we're basically supposed to say, like with the IVT theorem, we're supposed to prove that at a number, a given number. So in this example, and if you remember from the directions, it says that the number is 2. So n is the number. It basically wants us to prove that there's a point on the graph where y equals 2. So if this graph were continuous all the way from 0 to 3, and we know that for x equals 0 and where x equals 1, it's from 1 to 3, meaning that 2 is between 1 and 3, that we know there would have to be a point. Okay, I went a little bit too far there. Doesn't really matter though, just there would have to be a point where y equals 2, because it couldn't be continuous otherwise. If we know that it's continuous on this whole interval from 0, okay, I dropped my thing, from 0 to 1, we know it's continuous from this whole interval, and at x equals 0, it's 1, and at x equals 1, it's 3, then we know there has to be a thing at 2, because 2 is between 1 and 3. And it's continuous, meaning that in order to get from this 1 to this 3, it has to cross through 2 at some point. Otherwise, and it has to cross through 2 because it's continuous. It couldn't get to 3 unless without crossing through 2, unless you picked up your pen, which would make it not continuous. However, we know that it's discontinuous at 0.25, meaning it's not continuous from, or it's not continuous from the whole interval. We don't know what the y is at 0.25, but we do know that it's not continuous there, meaning it is. So like in this example, I would say the y, or you don't know, I would say at 2, it's kind of closer to 1/2, meaning it does cross through 2. But here, there's a hole. Number 44 basically wants you to draw 2 examples. One where it satisfies the fact that there exists a point on the graph where it crosses through y equals 2, which does in this, and then one where it doesn't. And so what that would look like is basically there would have to be a point at 0.25 or 1/4, 2, because we know it's not continuous there, but it's continuous everywhere else. So it would look like this. Okay. So 0, 1, 1, 3. This is hard to do with the camera up. And then 1/4, 2. So we know this doesn't satisfy the conclusion because it doesn't go through 2. So with IVT, we'll also have to do a different example to show that. But with IVT, you basically want to prove. So for example, for this, if it just told us without the discontinuous at 0.25, if it just told us that it's continuous from 0 to 1, then you can basically say that by IVT there exists a point on f of x where y equals 2, because you know that since it's continuous, it has to go, in order to get from 1 to 3, you have to go through 2. However, since it's not continuous in the whole interval, there is a possibility that at x equals 1/4 or 0.25, it crosses through 2. Therefore, there's no point where f of x touches 2 because it's discontinuous there. So, we can't prove with 100% certainty that IVT this is true here. However, if it's continuous from the whole interval, meaning that we know that there is no hole anywhere along this line, then we know that it has to go through 2 at some point. So I hope that helped explaining IVT. I'm going to do another example, probably 3 from the FRQ worksheet, or 5, because there's different parts of IVT, and I think it would help to actually see like a proof for IVT. But for now, I think this works. So hope that helped.